Okay, for this one, problem 21, it's another ice calculation. Ask you to calculate the, okay, so this one's now a weak base, right? It has that N. We're looking for the N. That's how we're going to recognize this as a weak base, not to mention it gives us the Kb here. Kb is this. There is an N in this molecule, so that's what we're looking for, either that N or a carbonate. Those are the weak bases. And it gives us that Kb, so we just write down the equation. Now this, you have to know these, right? You have to know so if this is a base, that means by definition of Bronsted-Lowry, base is one that accepts a proton, so it's going to differ with its conjugate acid on this side by a proton. So we just write down that structure, plus one proton on this side, plus the ion, and it leaves behind an OH because it comes from water, right, which is really a minus OH and a plus H over there. So our concentrations are as given. The equilibrium concentration is going to be minus X, and this is our expression. Now this is a very small K, so we now go to our small X approximation, and so the problem we solve is going to be one of 1.7 times 10 to the minus ninth is equal to X squared over 0.227, and then we just do the algebra and solve for X. And then we're going to have to, once we know the OH minus concentration, that's this, right? We're going to just make the POH. And that POH, again, is POH is minus the log of the OH minus concentration, right? And that's what's going to lead us to this answer there. Now this problem 22 is really just asking us, do you understand the chemistry? What will happen to these salts when we put them in water? So in this case, we're always looking at, some metal with an anion. In every case, it's going to be a metal plus an anion. That's really, an A minus that's next to an M plus of some sort. And then that's going to dissociate in water to make the metal plus the anion. So in each of these cases, right, this first one, Cn minus plus water, is that the salt of a weak acid? Indeed it is. It can accept a proton to make HCN plus, and that's going to leave behind then OH minus, right, because it steals that proton from water. Same thing with the next one. And this next one is lithium. Now, it's the BRO minus plus H2O. And that's the salt of HBRO plus OH minus. So yeah, every one of them. And this last one, C2H3, C2H3O2, that's got an organic one. So that's going to do the same and make acetic acid, HC2H3O2 plus OH minus. So yeah, all of them will form basic solutions. Now by the time you get to this problem 23, it just gives you everything. It lays out everything for you. What is the H plus or hydronium ion concentration of a 0.150 molar hypochlorous acid? So it's a weak acid, it gives the Ka. And then it even tells us what the reaction is, right? What the dissociation is. So it's all laid out for us. And that may throw you off. I don't know. It's a little bit different than the other questions. But don't let it, because it's all doing the same thing. We're going to make an ice table, and we're going to come down here to our equilibrium expression. 10 to the minus 8 is small, so that's going to be small. And then we're going to solve it the same way we've solved everything else, right? Times 10 to the minus 8 times that 0.150 is equal to x squared. So we take the square root of both sides, and that tells us what x is. In this case, x is the H plus concentration, which leads us to this answer of 7.2 times 10 to the minus fifth.